I'm too sure you're not going to have any problem with it. Let's move on to the application of the cosine rule. The application of the sine and the cosine rule. And we find that in arcs, segments, and sectors. Arcs, segments, and sectors. Let's take a few questions from some of this, and then we'll see the application of some of the things we've learned. We're moving on to arcs, segments, and sectors. Now, if you take your protractor and then you inscribe a part of a circle, that is known as an arc. A portion of the circle, or what we refer to as incomplete circle, is what is known as an arc. Again, if you draw a circle and you draw a line that is joining the circle at two different points, and it's not passing through, it may pass through the center of the circle, it may not. This shaded portion is what is referred to as segment. This portion from here to here, as long as it's not a complete circle, is what is known as the arc. And then the sector is almost like that. The only difference is it starts from the center of a circle. So the whole of this place is what is referred to as a sector. We have a major sector and a minor sector. We have a major arc and a minor arc. We have a major segment and a minor segment. All of these, there are different ways of measuring them. Measuring the perimeter, measuring the area of a circle, measuring the area of a sector, measuring the length of an arc. All of these things require their own the various formulae to determine them, and we're going to be looking at them shortly from now. The length or the perimeter of a circle is determined by the formula. Let me write some of them on the board. It will help you, because some of us have not heard about the perimeter of a circle before. It's the same thing as a circumference. If somebody asks you to determine the perimeter of a circle, the perimeter or the circumference of a circle, the formula of a circle, the formula is 2 pi r. The formula is 2 pi r. Again, if they ask you to determine the length of any arc in a circle, the length of any arc in a circle, the angle that it subtends at the center is very important. Now, the reason why when you are asked to determine the length of the total length of a circle round, the reason why we do not put theta, the angle subtended at the center, divided by 360, is because if you use theta over 360 concerning the formula for this, it will not change anything. And the reason is simple. What it should have been really, it should have been theta over 360 times 2 pi r. And this will be the angle subtended at the center. And if you look at the circle, the angle subtended at the center is 360. So if you do 360 over 360, you cancel it out. What you have left is this 2 pi r. And so that's why usually when they ask you for, or anybody is trying to talk about the length of a circle, the angle subtended at the center is usually not taken into consideration. But the moment it's not a complete circle, the angle subtended at the center becomes a serious issue. Like in the case of this one that we're going to look at now, the length of an arc AB If I have a shape that looks like this, and the arc AB subtends an angle at the center, let's say 30 degrees. If I ask you to determine the length of this arc, the length of this arc, the angle that is subtended at the center is a critical part of, is a critical requirement in determining the length of that arc. You do not disregard the angle, you do not disregard the radius of that circle. Those are very, very important requirements. Again, a sector is a combination of an arc and the two straight lines joined at the center. A sector is when you take into consideration the space there, but the arc is just a part of a circle. This is usually the center, and this is the radii. The two of them radii, single one radius. Again, a segment, like I've said, is a combination of an arc and a straight line. Is a combination of an arc and a straight line that joins the circle at two different, a straight line that joins the circle at two different ends. A sector like the arc is bounded by an arc and two sides. The area of a sector is usually determined, area of a sector is determined by this, theta over 360 times pi r squared. The length of an arc equals to theta over 360 times 2 pi r. Please do not mix them. A sector and a circle, they do not mean the same thing. Please do not mix them together. Do not mix them together. Again, I think it will be good for me to let you know that the diameter is the same thing as 2 radii. Okay, multiply the radius by 2. Multiply the radius by 2. That's the value of the diameter. In case a question presents itself and you are not given the radius of that circle, you are given the diameter. For you to determine the radius, you divide the diameter by 2. Again, it's good for me to say that the radius is equal to, let's say radius is equal to diameter divided by 2. Diameter divided by 2. So these are very important things you need to put into consideration. Again, let us take a few examples of determining an area of a sector and also the length of an arc of a circle, and then we can move to other things. Let's take this question. If the question asks you to determine the length of an arc, the length of an arc that bounds or that subtends, determine the length of an arc that subtends an angle of 144 degrees and the radius is 7 centimeter, and of radius 7 centimeter. Again, I already told you that the length of an arc, the formula is calculated using theta over 360 times 2 pi r. Theta is the angle that is subtends at the center. Again, theta in this question is 144. So we have 144 over 360 times 2 times 22 over 7, which is usually pi. So even if you are not asked to take pi at any given number, pi is usually 22/7, and then our radius is 7 according to the question. So you cancel 7 and then you will cut it. If you cut, you will discover that 2 here 180, 2 here again 90, you have 11 here. If you use 9 to cut this, you are going to have 9 in 14, 1, 9 in 54, you discover that it is 16, 9 here 10. Again, 2 will go 5, and then 2 will go here 8. So eventually you will have 88 divided by 5, and then you will discover the answer is 15.4. 5 in 8, 1 in 38. 5 in 8, 1. Sorry, yes. And you have 1 then in 38. It will go 7 times. And then finally, you will have 5 times 7, 35. Then you subtract 35 from 38, you have 3. And then you have a point. Then 5 in 30, you have 6. So we have 17.6 centimeter. 17.6 centimeters. The whole of the length of that arc that is subtended. Let's say, for instance, this is the angle that we're referring to. What this place is saying is the whole of this length is 17.6 centimeter. All right, cut. Yeah. Now, so this is how to determine the length of an arc. Again, we can also determine the area of the sector. So let's take a question. The question says, determine the area of the perimeter, define the area of a circle, of a sector, of a circle of diameter 7 centimeter. Let me read the question again so that you can pay attention to the details inside. It says you should find the area of a sector. Find the area of a sector when the diameter equals to 7 cm and the angle of the sector, again, the angle is 144. The formula for area of a sector is theta over 360 times pi r squared. Theta over 360 times pi r squared. So if you substitute the values, we are 144 over 360 times 22 over 7 times 7 over 2. The reason why we are dividing by 2 is because we were not given the radius, we were given the diameter. We're not given the radius, we were given the diameter. So you cut it, 7 cancel 7. 2 in 22, we have 11. 2 here, we have 72. Again, if you now divide, if you continue to cut it, you will discover that 2 in 72 will give us 36. 2 here will give us 180. 2 again will give us 18. 2 will give us 90. 9 will give us 2. 9 will give us 10. So eventually you have 2 times 11 and then divided by 10. 2 times 11 divided by 10. This is 2 that is left. 2 times 11 and then times 7. 2 times 11 times 7 divided by 10. And then if you do it well, what you're likely to have is 154 divided by 10. Mind you, the unit is centimeter square, and then eventually what you're going to have is 15.4 centimeter square. Please mind the formula. The formula is the most important thing, especially when you're not going to meet the exact figures in your exam. In this case, we use 7/2 because we were not given the radius, we were given the diameter, and we're given the diameter as 7 centimeters. So we use the formula, we use the angle that was given to us, 144 divided by 360 times 22/7 times 7/2 times 7/2, since the formula says pi r squared. And then we started cutting it. 7 cancel 7, 2 cancel 22, we have 11. Another 2 cancel 144, we have 72. And then again 2 cancel 72, we have 36. Then we cut 360 to 180. 2 in 36, we have 18. 2 in 18, we have 90. And then 9 in 18, we have 2. 9 in 90, we have 10. So we have 2 times 11 times 7. 2 times 11 times 7 divided by this 10. And then we multiplied all of this together. 2 times 11 is 22. 22 times 7 is 154. So we have 154 divided by 10, and the unit is centimeter square. Then eventually, if you divide 154 by 10, what you're going to get is 15.4. That is that about the area. All right. We've learned how to calculate the length of an arc. We've also learned how to calculate the area of a sector. Now I'm going to be teaching you how to calculate the perimeter of a sector. We've learned how to calculate the area of a sector, the length of an arc. Then how do we determine the perimeter of a sector? What if that kind of question comes in? The formula for perimeter of a sector. Perimeter of a sector. Perimeter of a sector is determined by length of the arc of that sector, length of arc plus 2 times the radius, plus 2 radii. Length of arc plus 2 radius. Look at this question. The angle subtended equals 90 degrees. Radius equals to 7 centimeter. So if the question asks you to find the perimeter of a sector that subtends an angle of 90 degrees at the center with a radius of 7 centimeter, what will be your reaction? You will use this formula that I've just written on the board, which is theta over 360 times 2 pi r, that's the formula for calculating the length of an arc, which we've already done, plus 2 radii. Again, 90, which is the angle subtended at the center, divided by 360 times 2 over 1 times 22 over 7 times 7 over 1 plus 2 times 7. Again, if you cut it, you have 9L1, 9 in 36, 4. 2L1, 2 in 4, 2. 2L1 in 22, 11. 7 cancels 7. So you have 11 plus 2 times 7, which is 14. And then again, the perimeter of a sector, not the perimeter of a circle, the perimeter of a sector now becomes 11 plus 24, which is 25 centimeter. 25 centimeter. So those are the 3 major things you need to learn in arcs, segments, and in sectors. But before, we've not done that of the segment. But for arc and sector, you will be confronted with questions that will require you to determine the length of an arc. You will be confronted with questions that ask you to determine the area of a sector, and again the perimeter of a sector. Now let's quickly move on to the area of a segment. The area of a segment. To determine the area of a segment, the area of a sector is first determined, and then that of the triangle. Please let me explain this. Let me clean this so that we can concentrate on the segment. The segment is a portion of a sector. Once you, this is a circle. This is the center of that circle. You have a radius like this. This is the indication of the center of the circle, and then you have a line that is joining one edge of the circle to the other. This line is referred to as a chord. It's referred to as a chord. Now, the portion that is bounded by the chord is what we refer to as the segment. This shaded portion is known as segment. Segment. And then the whole, let's say this is AB. The whole of the OAB is known as sector. Then from A to B, like this, on the circle is what is known as the arc. Again, from this point, like this, until you get to point B, is known as arc. Minor arc. The shaded portion that is bounded by chord AB is known as segment. Again, the whole of this shape from point O down to A, down to B, back to O is known as the sector. Everything is known as the sector. Now, if the questioner asks you to determine the area of a segment, like I already said in the note, what you do is the area of a segment, equals to area of sector minus area of triangle. Area of sector minus area of triangle. Area of sector minus area of triangle. The whole of this is the sector. The small portion inside is the triangle. I do not want you to confuse this with sector. This is triangle anyway. This is triangle. And the whole of this shape, everything here, is what we refer to as a sector. So this is the major sector. Major sector. And that refers to the inside is the minor sector. So let's quickly take a question, and then we can forget about we can forget about arc, sectors, and segments. Now the question says we should determine the area of a segment, in which case it subtends an angle 90 at the center, and the radius is 7 centimeter. The radius is 7 centimeter. Look at this. If you have a question that looks like this, this is a right angle, the center 7 cm, and then you've been asked to determine the area of this segment. So first of all, you determine the area of sector. Area of sector equals to 90 over 360 times 22 over 7 times 7 times 7. 90 air 1, air 4. 2 air 11, 2 air 2. So what you have is 11 times 7, which is 77, divided by 2 centimeters square, which again can be written as 37.5 centimeter. Is it 38? Sorry, because 2 in 7 is 3, 2 in 17 is 8, and then 0.5. So 38.5 centimeters squared. Area of triangle. Area of triangle. Like I already said, this is a right-angled triangle. And if it's a right-angled triangle, you can use a simple formula for calculating the area of a triangle on it, which is half base times height. But again, This triangle they didn't show to us which one is a base or which one is a triangle. I mean, which one is the base or which one is the height. So it's better for you to just use another formula, which I'm sure you are well acquainted with, which is half AB sine theta. Half AB sine theta. So you have half AB sine theta as the formula for calculating the area of this triangle POQ. Triangle POQ. So you have 1/2